Okay, let me see here. Today we're going to show you how to plot sine waves using degree. First, we'll open a live script, like what we did before. And then in our last recording, I already have introduced how to clean up the space first. You run this code. You'll see this command window is cleaned. And then these workspace are cleaned. Now we have a new section. Then we set up the initial parameters, set up the frequency, calculate the omega from frequency, which is 2 pi times f. So for one cycle, it will be 1 divided by 60 hertz. So we can also say divided by f. And then we set up the time step. The time step would be 1 divided by f. This is one cycle. And then that means we want to plot out 100 points in one cycle. And then the length of it is, this is one cycle. We want to plot out altogether 3 cycles, okay? So we set up the t from 0 to this time step until 3 cycles, okay? So the voltage is 120 volts, which is the nominal voltage for a residential household, okay? So next we're going to plot out. This is a new section. Okay. So we introduced our first method to plot out everything in radians. So if you use cosine, everything here is in radians. So when I run this, I haven't set this up yet, so I'm going to just run it. Okay, so you can see that this sine wave, it starts from 0 and then it had reached this maximum value. And then if we because we put hold on, so the next figure we plot out, it will be just overlaid with this one. So let's say lagging 30 degree. So 30 degree will be pi over 6. Okay, so when we plotted that out, we want this to be in blue. And then make it thinner. And then make it line, so we can run it again. You can see that when we have an angle, that theta here, this is the initial angle, it will be 30 degree lagging because this is minus, right? So if it's a plus, and then we put that in green, run that. You can see this will be plus, so it will be leading, okay? So how we're going to do this if we want to input a degree. So can we, let me just use another section to start with. Copy this part. And then make this a figure 2, okay? So I mentioned in our last lecture, we can put this in D. So everything inside here will be degree, okay? So this will be 30 degree. So can we simply do that? Let's see if we plot that out, what will happen, okay? You can see that this is obviously not 3 cycles. It's very short. It's a sine wave, but somehow it's just the start of it, okay? So what happened here? This is because if you put D here, everything inside this parenthesis should be in radius, in degree. So here we need to change this radian to degree. So this is a function. It will change all the value inside this parenthesis from radian value to degree, okay? So now let's just see when we do this, whether or not it will give me the correct figure. See, now it's the correct figure. So when you using cosine D, you need to make sure that you use radian to degree for the omega t as well. Okay, otherwise you will get this curve instead of a sine wave. Okay. So there's another way for you to actually plot out this, which is, let me show you a third way of doing that. So let's call this as method 2. And this is our method 3. So in our method 3, we will actually use this feature. A cosine theta is actually the real part of an exponential function. You can see this is actually in page 2 of the book. So you can take a look at the book. So if we follow that kind of expression, then we can have a real part of BA RMS value times square of root of 2. And this EXP, this is the rotation part, which is 1J times omega t. And then we have this angle part, which is 1J times minus pi. Let's say this is 1/6. Okay, so this would be our minus 30 degree. This is a plus, so I'm going to plot out the minus. Let's see what will happen. Okay, let me change that from green to blue. Okay. Let me see what happened. Oh, here, sorry. Let's accidentally delete this one. Okay, so this will be blue. Okay, so you can see that the other way of plot out the sine wave is simply to plot out the real part of this exponential function with the 1J with this exponential part of the representation. Okay, so this is our third way of representing that.